So now let us learn how to do question number 1 in 5th question. So this is from exercise 8.4. The question goes like this. We have to prove that cosec theta minus cot theta the whole square is equal to 1 minus cos theta by 1 plus cos theta. So in questions of this type, wherein we have to prove that something is equal to something, there are various ways in which we can do them. Number 1 is we take the left hand side and then we bring the right hand side. Or we can also take the right hand side and then we bring the left hand side. Or we can take both of them simultaneously and derive at a common answer. So we will explore all these three in different type of problems. For the first subdivision, what we are going to do is we are going to simplify the left hand side. So I'm going to take the left hand side and I'm going to simplify it. So the left hand side goes like this. It is nothing but cosec theta minus cot theta the whole square. So this is the left hand side, and I'm going to simplify it by converting each trigonometric ratio in terms of sine and cos. So what I mean by that is, we all know that cosec is nothing but 1 by sine, and also, so I'm writing it as 1 by sine theta, and also cot theta is nothing but cos theta divided by sine theta. And then we have a whole square here. So this is how we convert it. Now we have converted cosec and cot in terms of sine and cos. But why do I do this? So that is the question. Because in the right hand side, it's very clear that it is in cos theta. So we are trying to convert everything in simple trigonometric ratios, which are nothing but your sine theta and cos theta. Now, no need to take LCM because there is a common denominator already. So it is something like this. 1 minus cos theta by sine theta the whole square. So this is how it is. No need to take LCM. It's just 1 minus cos theta. The numerator just gets subtracted and then you have a common sine theta whole square. Now in the next step, let me take this square individually to the numerator and denominator. Now the numerator becomes 1 minus cos theta the whole square and the denominator becomes sine square theta. So as we keep solving this, we should always parallelly look at the right hand side and what is expected out of us. So here the target is only cos theta, but in the denominator we have a mismatch which is sine theta. But in the numerator it is kind of matching. We have arrived at cos theta, but in the denominator it is sine theta. So if we can convert the sine theta somehow into the cos theta value, then we are nearing the solution which is fully in terms of cos theta. So for that, what we do is we know that sine square theta plus cos square theta equal to 1, which is the first identity. And from this, sine square theta equals 1 minus cos square theta. So we know this step is very important. And when we substitute this here, we get 1 minus cos theta the whole square. The numerator remains unchanged, divided by sine square theta is nothing but 1 minus cos square theta from the identity. So this is something that we need to know. Now, what we can do here is we can have the numerator as such. So some of you might be wondering why I am not taking the whole square. Because I need this 1 minus cos theta. If you keep looking at the right hand side, it's very clear that we need this 1 minus cos theta. So let's not disturb it. Of course, there is a square which needs to be eliminated, but let's see what can be done. Now, in the denominator, you have 1 minus cos square theta, which can be written as 1 square minus cos square theta, because 1 square is 1. So in the next step, we get 1 minus cos theta the whole square divided by, this looks like a square minus b square. That is 1 square minus cos square theta looks like a square minus b square, which will be a plus b, that is 1 plus cos theta into a minus b, that is 1 minus cos theta. Now 1 minus cos theta and one of the 1 minus cos theta in the numerator will get cancelled, leaving you with 1 minus cos theta divided by 1 plus cos theta, which is our required right hand side. So this brings an end to this answer. So two things that we should be very careful here is, one, why am I converting the cosec and cot theta in terms of sine and cos? Because In the right hand side, we are expected to bring cos theta. That's why we are converting. And second one is why we are not taking this whole square inside. I mean, why we are not applying a minus b whole square is because when we apply a minus b whole square, it becomes something like 1 minus 2 cos theta plus cos square theta. But this entity called 1 minus cos theta is required in the numerator in the right hand side, as you can see. So we have already gotten it. So why to disturb it? So that's why we are not taking the whole square. Eventually, that is getting cancelled with the denominator. So this is something that we need to know. And also here in this step, why we are writing this 1 as 1 square is to make it appear as if it resembles a square minus b square, so that we can write it as a plus b into a minus b here and cancel one of the a minus b term and the numerator term to get the required answer. So this is all about first subdivision. Let us look at second subdivision, how to do it. Now, it's very clearly given that, it's very clear that in the question, it's given only in terms of sine and cos, left hand side. So one part of our work is done. They have already given it in sine and cos. So we can directly take LCM. So here LCM is whatever is missing here, that will be the LCM. In the sense, if you take the whole of this denominator, which is 1 plus sine A into cos A is missing here, that will be the LCM, and 1 plus sine A is missing here, so that will be the LCM. So when you do this, you will be getting cos square A plus 1 plus sine A the whole square, whole divided by 1 plus sine A into cos A. So this is something that you should know. So this is quite important. So here we are multiplying it by cos A in the numerator as well. So cos A into cos A in the numerator becomes cos square A. Similarly, here we are multiplying it by 1 plus sine A because that is the missing term. And the numerator also we are multiplying it by 1 plus sine A. There is already 1 plus sine A in the numerator, which becomes 1 plus sine A the whole square. Denominator is just a multiplication of both the terms. So now when you multiply the, when you expand the numerator, you get, so it is a plus b the whole square. You get a square, which is 1 square 1, plus 2ab, which is 2 sine A, plus sine square A. This is how we expanded. Just a minute. So in the numerator, we get on expansion of this, we get like this. That is a square, that is 1 square 1, plus 2 into a into b, 2 into 1 into sine A, 2 sine A, plus b square, which is sine square A, whole divided by 1 plus sine A into cos A. So some of you might be wondering, in the numerator alone I have expanded. Why not the denominator? Why not I make it 1 into cos A and sine A into cos A? That is because we need this cos A, because if we have this cos A as such, finally if everything gets cancelled and we get a 1, we get 1 by cos A and we get CK, which is there in the right hand side. So that's why I'm just keeping the denominator untouched, because it may get further simplified and we will have only cos A, which will give you CK at the end. So now what happens is, it's very clear that cos square A, this term, and sine square A will get added and will give you 1 according to identity. And there is one more 1 here, and then there is 2 sine. So this is how I'm simplifying this, and denominator I'm keeping it as such. The same reasons which I told you previously. So you get like this. So this is by identity. According to the identity, which is sine square A plus cos square A is equal to 1. So now what has happened is, both these terms together has become 1. And there is one more 1 which is there. And also we have 2 sine A. Now this cannot become 4 sine A. That is very, very important, because this 2 belongs only to sine A, which is a different term. So this becomes 2 plus 2 sine A, not 4 sine A. It just becomes 2 plus 2 sine A divided by 1 plus sine A into cos A. Now, in the numerator, we can take this 2 as common out from both the terms. So we get 2 into 1 plus sine A. In the place of 2, you get 1. And denominator, you have 1 plus sine A into cos A. Now we can see clearly that this 1 plus sin A term and the other 1 plus sin A term will get cancelled, leaving you with 2 by cos A, which can also be written as 2 into 1 by cos A for our convenience. This can also be written as 2 into 1 by cos A. And we know that inverse of cos is sec. So you get 2 sec, which is the right hand side. So this is how we bring the right hand side from the left hand side. So this brings second subdivision to an end. Now let's try to understand third subdivision. The left hand side looks quite a bit complex. So what we are going to do is we are going to convert the terms in the left hand side into simple trigonometric ratios, which is sine and cos. That's what we are going to do. So the numerator here, that is tan theta, that will become sine theta by cos theta. So this is the conversion that we need to know. And in the denominator, we have 1 minus cot theta. Now this cot theta can be written as cos theta divided by sine theta. So I'm converting everything in terms of sine and cos. So this is how we get it. Now we have another term, cot theta in the numerator, which is nothing but cos theta divided by sine theta. And in the denominator, we have 1 minus tan theta, which is sine theta divided by cos theta. So this is how we do. So after converting them, the next step is to take LCM in the denominator. So again, I'm not going to change the numerator, which remains sine theta divided by cos theta. And in the denominator, you have sine theta minus cos theta divided by sine theta. This is the LCM in the denominator. I repeat, if you consider this step, please look at red color. If you consider this step, here you have divided by 1. So sine theta is the LCM. So you do into sine theta, the numerator, you get sine theta minus cos theta whole divided by sine theta, and that is what I have written over here. This is something that we need to do. And you have a plus term, and you have cos theta divided by sine theta. Divided by. Now, when you take LCM again in this term, you get cos theta minus sine theta whole divided by cos theta. So this is the LCM for the second part. Second part in the sense denominator. So this is what we are getting. Now, in the next step, what I'm going to do is I'm going to take this term to the numerator and make it reciprocal like this. Both the terms to the numerator. Now, what would happen is this would become sine square theta divided by cos theta into sine theta minus cos theta. Plus, likewise, when this goes, it gets reciprocal. So cos theta and cos theta will become cos square theta divided by sine theta into cos theta minus sine theta. So this is something that we need to know till here. Now let me re-explain this step. What happens is when this term goes to the numerator, it gets interchanged. What I mean by that is sine theta goes to the numerator and sine theta minus cos theta comes to the denominator when it goes up. So this sine theta and this sine theta becomes sine square theta. You can see here. And the denominator cos theta into sine theta minus cos theta. I'm just writing it like this. Likewise, in the second part also, when this goes to the numerator, we get cos theta divided by cos theta minus sine theta. Just gets reversed, and cos will become cos square theta, as you can see here, and sine theta into cos theta minus sine theta remains the same. I have even used brackets to show the distinction. This is how we get this step. Now we are going to take LCM for this step. And it's not quite easy because all the terms are different. We have cos theta, we have sin theta minus cos theta, we have sin theta, we have cos theta minus sin theta. All four are different terms. In order to make the LCM process a little simplified, what we are going to do here is we are going to do like this, wherein the numerator is sin square theta. The first term remains unchanged. I'm just having it like this. I'm not changing the first term, but with respect to the second term, you have cos square theta divided by sin theta into, I'm converting this cos theta minus sin theta into sin theta minus cos theta. This is the only change that I'm making to the previous step. As you can see here, I have changed cos theta minus sin theta into sin theta minus cos theta. But this change can be done only if you introduce a negative sign. Only then the terms will get interchanged. If it is a positive sign, then it's not a problem. We can interchange it anyways. But if it's a negative sign and you're going to change the order, then there is a negative sign coming in the outside, which will actually make the positive sign here negative. So this positive and this negative will interact and they will become negative. So we get something like this. So if you keenly observe, the only change that has been made is this cos theta minus sin theta has been converted as sin theta minus cos theta. Also, this positive sign here has been converted into negative sign. Because of this change, the terms have been interchanged and you introduce a negative sign. So this is something, this step is very, very important. So why have I done this? So now you can see these two are the same. So taking LCM is very easy. So which means that this is the underlined red color underlined thing is the common thing. So the only LCM is sin theta here and the only LCM is cos theta here. So that has made the process a little bit easier. So now here the LCM is only sin theta. So you do into sin theta into sin theta. And here the LCM is only cos theta because that is the only missing term. So you do into cos theta into cos theta. So with this understanding, the numerator would become sin cube theta. Here, as you can see, the numerator will become sin cube theta and the right hand side numerator will become cos cube theta whole divided by, after taking LCM, what all you're left with? You're left with 1 sin theta, you're left with 1 cos theta, and also 1 common sin theta minus cos theta. So this is the step we are sitting with now. So what we do now is we're going to apply a cube minus b cube formula. So let me write the formula here. So a cube minus b cube is nothing but a minus b into a square plus ab plus b square. So this is the formula. So we are going to apply this formula because the left hand side resembles sin cube theta minus cos cube theta. Now it resembles a cube minus b cube where a is sin theta and b is cos theta. So now what we get is sin cube theta minus cos cube theta. This will become sin theta minus cos theta into, on applying the formula, sin square theta plus sin theta cos theta plus cos square theta whole divided by sin theta cos theta into sin theta minus cos theta. So this is very important. Now sin theta minus cos theta and sin theta minus cos theta will get cancelled. I repeat, we are applying a cube minus b cube to this place. So we get a cube minus b cube, which is equal to a minus b into a square plus ab plus b square. That is the formula. Now this is a minus b. This is a square plus ab plus b square. We have applied this formula here. So a is sin theta and b is cos theta. Now, after expansion, in the denominator sin theta minus cos theta and the numerator sin theta minus cos theta will get cancelled, leaving us with this. Now, even now here, this can be further simplified as 1 plus sin theta cos theta divided by sin theta cos theta. How I got 1 is, again, sine square theta plus cos square theta will become 1 according to the identity. So this becomes 1, and whatever you're left with is sine theta plus sine theta cos theta. So this becomes 1. Sine square theta plus cos square theta is 1 plus sine theta cos theta by sine theta cos theta. Now the last step goes something like this. So now I'm going to divide this sine theta cos theta separately with 1 and the other term. So the other term is sine theta cos theta by sine theta cos theta. I'm continuing this here to get something like this. So this has been continued here. So you get like this. Now here cos theta, sine theta. So basically what I'm doing is I'm splitting the denominator for each of the terms. Now you get something like this. Now we know that 1 by sine theta is cosec theta and 1 by cos theta is sec theta, and all of them after getting cancelled is 1. So you get 1 plus sec theta cosec theta, which is the right hand side. So this is how we solve subdivision 3. So let's do the fourth subdivision. There are some problems wherein we might have to solve both the left hand side and right hand side simultaneously and arrive at an answer, common answer. This is one such problem. So I'm going to take the left hand side and I'm going to convert it into simple trigonometric ratio, which is cos. So now this 1 plus ck can be written as 1 plus 1 by cos a, because inverse of sec is cos, and also in the denominator sec can be written as 1 by cos. So this is something that's important. And then in the next step, I'm taking the LCM in the numerator alone. So which is cos a plus 1 by cos a. And then the denominator, I'm trying to bring it upwards like this. So you know it gets reciprocal. I repeat, I'm taking the left hand side and the ck has been converted into 1 by cos a in the numerator as well as the denominator. So wherever ck comes, I've converted it into 1 by cos a. And in the numerator, I'm taking LCM, which is into cos a, as you can see here. So now you get cos a plus 1 by cos a. And this denominator, I'm taking it to the numerator, it gets reciprocal and it becomes cos a by 1. Now this cos a by 1 and this cos a will get cancelled, leaving you with cos a plus 1 by 1, which is of course cos a plus 1. So this is the simplified version of left hand side. Now what we do is we take the right hand side. Now the simplified version of left hand side has only cos in its simplified end. So now what we do is we have to convert this right hand side, which is sine square a. So sine square a can be written as 1 minus cos square a according to the identity, according to first identity. Now this 1 can be written as 1 square. So why I'm writing like this? In order to resemble a square minus b square format. Now the next step, what happens is this becomes a plus b into a minus b. Now 1 plus cos a into 1 minus cos a divided by 1 minus cos a. So this is what we get. And this 1 minus cos a and this 1 minus cos a get cancelled, leaving us with 1 plus cos a, which is nothing but cos a plus 1. So since we have got both the left hand side and right hand side as 1 plus cos a, we conclude that this is true. So hence proved.